Okay, so we are live. Let me share my screen. Is it visible?
Yeah, it's visual.
Okay, so but today's Leetcode POTD is valid anagram. So we have been given two strings, string S and string T, and we need to find whether they are anagram or not. So what is the anagram? And as two strings are called anagram if both contain same number of characters with the same number of frequency. For example, there is a string anagram, okay, a string anagram and a string nagaram. If we check about their correct number of characters and a frequency, A is having 3 times in anagram, and in nagram also A is 3 times, G is also 1 time. So we can see that both are having exactly same number of characters with the same frequency, so they are anagram strings. If we see another example of rat and cat, they both are not an anagram because A is 1 time, here also A is 1 time, it and it's also having 1 time, but they both have two different characters T and C, which are not different each other, so they can't be called as anagram. So how we can approach this problem is, first of all we can use an another map to maintain count of characters, and that time we can compare that if both are having same number of characters with same number of frequency, then they could be considered as an anagram. So let me write this code. First of all we can check if both are of same length. If they are of different length, then we can just simply return false, as they can't be anagram. By doing this we just first of all incrementing the frequency of a particular character in our map, and if that character is also found in our another string, then we're decrementing it. Sorry, we're just decrementing it. By this our overall another map will have different types of characters with a value 0, and if they have a if its value is not 0, then we can consider that they are having some difference in characters frequency or difference in characters. So after adding them to map, we can simply traverse in our map, and we can check that if our speed of second is not equal to 0, then we can simply return false, and that and we can simply return true if our all of the condition doesn't met. Let's try submitting it. Yeah, as you can see, it got submitted. So this was all for our lead course POTT. So now over to you, Sangam.
Just give me a second, huh? Yeah. So, guys, the question that we have been asked today in today's GFG PODT is that there is a length and that is given to us. Yeah. And we have to create a string of this length, but the provided limitations that we have been given here is that we can use a for any number of time that we want, but we can use b only one time and we can use c only two times at most. So these are the constraints that we have been provided to solve this question. So the ultimate thing is that let's just assume that the current length that is given to us through which we have to think of length something like this. Let's just assume it to be 6. Okay, so we have to create a string of length 6. Now what we have to do is we just have to count out the number of which can be used in order to create the string. The first one will be that only all the string members should be a, that we are not considering anyone else, we are only considering a as the string member. The second case is that we can choose one b and the rest elements to be a. The third case is we can choose only one c and the rest elements to be a. In the fourth case we can take one b, one c and the rest to be a. In the sixth case we can take one b, two c and one a. And in the fifth case we can take 2 times c and 1 times a. And then what we have to do is we just have to count out the number of ways we can arrange these elements, and when we find those ways out, simply add the combinations that we are getting from each of these cases, and that would be our ultimate answer. So let's just see that how many of these cases that we can form. The first one is that the length that should be given to us, and in this case it is what? It is 6. So let's take case 1. In case 1 what we have already discussed is that we are going to take each string element to be a. So in this case, if I have taken a, I can arrange it, I can place it at anywhere else and the arrangement would look similar. There would be no difference in the looking of that arrangement. So thus the total case that I am going to get by arranging the string elements to be with a is only 1. Okay. Now let's just move on to the second case where we have about, let's say, 1b and the rest elements are to be a. So as you can see in the case that we have been given here, we are taking b in this position. So that would be the first case that I have taken b in this first position, and the rest of the string elements are a. Now I can change this position of b to be at second index, to be at third index, to be at fourth index, to be at fifth index, or to be at sixth index. And by this way we have to some total of 6 arrangements that we are going to get from this case. Then we move on to the third case. And what is the third case? In the third case, we have one C and the rest elements are to be A. So this case is literally similar to the one that we have done in the previous case, because we can either arrange C here, we can either place it here in the second row, we can place it here in the third, fourth, fifth, or in the sixth place, and the rest elements are to be A. So there are only 6 arrangements that we are going to get from this case, so that is why we are taking it that way. Then comes the fourth arrangement. Now what was the fourth arrangement? What was the fourth case? So as you can see in this, it is stated that 1b, 1c and 1a. So in this case we are taking 1b, 1c and the rest elements are to be a. So in order to solve this case, you can see one thing that either I can place b here, 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 like I can place it anywhere else, but the arrangement would be different because of these two cases. Because if I place b here and what, like what do I mean by that is, let's say if I place b here and c here, that would be one arrangement, but if I place b here and c here, that would come out to be a very different kind of arrangement. So in this case what we have to do is we have to find combinations, like how many number of ways I can arrange this one in this whole combination, in this whole list of element. So in this way you can see that we can place b in, we have one element to be placed and there are six places in which we can place. So we are using the combination formula to solve this case. Okay, so same goes for the one c that we have to place here. So if we I had placed b, let's say in the first position, then the remaining places would be what, five. So there are five places in which I can place my c. So that is why five places, and the element that I have to arrange is only one. That is why one is there. Then for the rest of the places, as you can see in this case too, one is there, second, third and fourth is there. So in those cases we have four a's. So four places are left and four a's are there. So we are going to use this combination formula to calculate the places for a. Now after we do that thing, as we know, the formula of combination is n factorial by r factorial and minus r factorial. In this case, 6 would be here, n factorial, then r will be at like 1, and then n minus r would be 5. So it would be something like that. Now after we do the calculation of these, what we have to do is we just have to do the addition of these. Okay, whatever I'm going to get from here, whatever I'm going to get from here, whatever I'm going to get from here, just do the addition of it. After I do the addition, the sum of the thing or the final thing that I'm going to get is this result, that is n multiplied by n minus 1. So for this case I am getting this as a result, but for the previous cases, for case 1 the simple answer was only 1, for case 2 it was the size of the string, for case 3 it was the size of the string, but for in this case we have to do the addition of these numbers. So in the fifth case what we have to do is we have to do the addition of these. So in our fifth case what we have to do is we have to add ba. Okay, so now in this case too we are simply going to allow or apply the arrangement that we have done in the previous case, and that is we are using the combination formula because there are going to be number of ways we can arrange these elements. Because if I place b here, C here, that would be a different arrangement. Similarly, if I place C here, that would be ultimately different arrangement. So to deal with these arrangements, we are going to use combination formula, and that is one is the element that I want to place, and the number of places that are assigned to me are 6. So in 6 places I have to place one element. Then for to C, here you can see that the remaining places that I have after placing B in these any of the places that are given to me, there are 5 places left. So in those 5 places the only 2 I can or I have to assign. So that is why this formula is used. And then for the remaining places, because 3 places would be left and 3 A's that I have to apply, this formula would be applied. Now after we do the calculation of this, that is the addition of this and the addition of this, we are going to get this formula as the result, which is 10 or n multiply n minus 1 multiply n minus 2 divide by 2. So this is the formula that we are going to get. Now comes the sixth case. In sixth case, what is the scenario? We have 2c and the rest element to be a. So they can be whatever they want to be, but the rest element are to be a. So we can place c here. That would be one arrangement. And another arrangement can be that I place c here and here. Then the third arrangement where I place c here and c here. So there can be multiple form of arrangement that we can form. And we are going to use the combination formula for this thing too. So two places we have to put c. So 2 we have taken here and 6 are the places that we have given or we can assign it to. So we will calculate it by that. Then after placing these to c, the remaining places are to be placed by a's and the remaining places are left to be 4. So we will use this formula, and ultimately the calculation that we are going to get from this formula would be n multiply n minus 1 divided by 2. So after finding all these arrangements, okay, the last thing that I have to do is just do the summation of them. So it will be addition of this, addition of this, addition of this, addition of this, and this final element, and ultimately we will have the results. So that is what we are doing, guys. First of all, we are detecting that for the longest cases, what would be the scenario that we are going to get. And these are the scenario that we are going to get. Then we are just creating cases for them. And for each of the cases, we are finding their respective formula. These formula we are getting is just by solving these equations, because this equation result will to be ultimately one, and the rest we can solve these equations, and that is what we are going to get. Similarly for these equations, and similarly for these equations. And then after, in the final thing, we are just doing the summation. We are doing just the summation. So now let's just move out to the code to see how it is done. And that is what I have done in this case. The first was that we are only take the single element. Then the second case we are only taking the n size. Then in the third case is again we are taking only the n size. Then in the fourth case, as I already described it to you, in the case fourth we are using this one, this formula, and that is what we have done in this case. Then in the fifth case we are taking this formula, this one, and that is what we have written in this case. And then for the sixth case it would be the last formula. And if we simply submit this code, it would work perfectly fine. So as you can see, the code is working perfectly fine. With that, today we have solved both GFG and Leetcode POTD. We hope that you guys be able to understand it. With that, over to you, Shivam.
So yeah guys, thanks for joining with us. We will catch you up tomorrow.
Yeah, guys.